This is the session, by the way. So relax, enjoy. Hello everyone, and this is basically why we don't go to IT to ask them about IIS. Okay, this is why we are here to learn about how IIS actually works. So, hello everyone, my name is Ido Flatow. I come to you from Israel from a company called Seller Group. I'm an IIS MVP and an ASP.NET MVP, and I do a lot of IIS training, web development training, even wrote a couple of books on the subject and a couple of courses for Microsoft. And I'm also, on my free time, which I don't have a lot of it, I manage the Israeli Web Development User Group, which is hosted in Microsoft. So if any of you are planning a trip to Israel, if you're during the third week of the month on Tuesday, join us. The sessions are in Hebrew, so I'll give you a translator, but it's going to be fun. Okay. So our session today is about IIS for developers. So just with a show of hands, who here uses IIS? Cool. Who uses Linux? No. Okay, that's cool too. So first of all, IIS. What is IIS? Basically, it's a web server. Today, it's actually more than that. You can actually host services such as WCF on IIS, even with TCP endpoints. But basically, IIS is a web hosting environment. It comes in two flavors. Either the full-blown IIS, which you get with Windows machines, or you have the small version, which is called IIS Express. Okay, we look at IIS Express later on during this session. IIS basically provides you a lot of features for hosting web applications. It has a pipeline that you can plug into and add your own custom code. It has a lot of logging and diagnostic options. It has that famous application pool, which we will look at in a couple of minutes and see exactly how it works. And it provides you with options to increase the performance of your applications, do stuff like compression and caching. And all of that stuff are simply wrapped in a small box called IIS, which you just need a couple of clicks to install in your server. Okay? Now, IIS is quite old. The first version, the normal version of IIS, which you can actually call IIS, before that you had stuff like Personal Web Server on Windows NT. We won't look at that. But the first real version of IIS was back in Windows 2000, IIS 5. I hope no one is still using that version. Anyone? Don't show your hand. No, don't raise your hand. The same version, almost the same version exists in Windows XP. I hope no one is still using Windows XP with IIS 5.1. Stop using that. That's not IIS. That's a piece of you know what. The next real version of IIS, the IIS server that we actually used in production, was IIS 6 in Windows 2003. IIS 6 was the first version that had the concept of application pools. Wow. The next version of IIS, which kind of just shuffled the whole deck of cards, was IIS 7, which required Microsoft to rewrite all of their courses because they changed the user interface. Okay, now how many people migrated from IIS 6 to IIS 7? How many of these people had to relearn where everything is in the user interface, right? Okay. You just needed to go over each and every one of the buttons just to figure out where your configuration went. So basically, this is the current interface of IIS. It changed a bit over time. We had IIS 7 and then we had IIS 7.5. In the past 2 years, we've had IIS 8 on Windows Server 2012. And just a year ago, we got IIS 8.5 on Windows 2012 R2. There are a couple of new features of IIS 8.5. I will point them out at the end of the session. There are not that many. They should have called it IIS 8.1, like Windows 8.1. But there are still some cool features. A lot of the new features were in IIS 8, like shared certificate storage and stuff like that. We might look at some of these features later on. So first of all, let's talk a bit about IIS concept just to get a common ground with everyone. Let's see with a show of hands. How many people are familiar with the concept of, not your computer, of course you know your computer, websites, the difference between a website and a web application, okay? So basically, first of all, website is the basic concept of your hosting environment. It gives you either a DNS address or a port or both of them, okay? It just splits your hosting to different sections. You can host your application on one website, you can host a SharePoint server on another website on the same machine. Each website will simply listen to a different port or to a different DNS address, so you can show your client that you actually have two different web servers, but they're actually the same web server. Underneath a website, we create web applications. A web application is basically classical ASP, ASP.NET. You can even do PHP, SAPI filters, all sorts of frameworks that can actually run under an IIS web application. Now, don't confuse web application with an application pool. It's not the same. We'll see exactly what an application pool is. But basically, a web application is one application that you're hosting inside IIS. By the way, the website itself is a web application. Okay? The root website is actually a web application that you can put files in and host them. So we do have the concept of application pools ever since IIS 6. Application pool is just a basic way to group web applications under a unit of work, a worker process. Okay, we'll see in a couple of minutes exactly what application pools are and how they are configured. I just want to go over the basic terms just to verify everyone is on common ground. And of course, we have the concept of virtual folders, physical folders. The basic idea of IIS is it doesn't matter where you host your files, IIS will present them as being on the machine itself. So I can even bring files from a UNC, a network share, okay, and host them in my IIS. That way, by the way, it's the best way to host the same content in different web servers. If you have a load balancer and you have a couple of servers behind the load balancer, just put your files in a shared file storage and use a network share instead of copying the files to each and every one of the IIS servers. Okay, tip number 1 for today. There will be plenty. Prepare notebooks and pens. So let's take a look about the biggest architectural changes in IIS that came out in IIS 7 and on. So first of all, this was actually before IIS 7. How many people thought until this moment that IIS listens to HTTP communication? Come on, you all thought so, right? The basic concept of IIS is that we thought that IIS listened for HTTP communication, listened on port 80, and transferred all the requests to the correct application. That's not actually how IIS works, okay? Actually, ever since Windows 2003, there is a kernel device driver that listens for HTTP communication. Whenever you are using IIS or stuff like WCF or any HTTP listener in C++ or in .NET, there is actually a device driver in Windows that opens a socket for you. So has anyone ever tried to listen to the same port from 2 different applications? Yeah, if you tried that, that probably crashed, right? But have you ever tried doing that, for example, for a WCF service that listens on port 81? Anyone ever tried that? Multiple WCF services listening to the same code? That's actually supported, okay? Because different applications can listen to HTTP communication on the same code. That's exactly how IIS works. So basically, there is a driver in your operating system. It listens to HTTP communication. Every IIS application and every other application that uses HTTP registers itself in that kernel device driver, and that kernel device driver just picks up the messages and sends them to the correct application. IIS is just one of those applications. So ever since IIS 7 and the concept of WAS, Windows Process Activation Service, IIS is not actually the listener of HTTP. That's how we can actually get TCP listeners in IIS, MSNQ listeners in IIS for WCF services, of course. Now, it's not that HTTP driver only listens for communication. It actually manages the entire SSL negotiation. It actually has its own caching mechanism. Okay, so if you ever saw in IIS kernel level caching, that's the piece that does the caching. It even controls the quality of service of your HTTP connections, the default timeout of the connection, the maximum connections the IIS can handle. Okay, everything that has to do with HTTP communication is handled by that piece of software, and basically IIS is just another application. Okay. The second concept that changed in IIS is the pipeline of IIS. This was a very big change between IIS 6 and IIS 7. If you ever saw in IIS 7 the options of classic pipeline and integrated pipeline, okay, this is what I'm talking about. The classic pipeline is what we had in IIS 6. Everything went through native modules written in C or C++, which handled the incoming request and the outgoing response. And every one of those pieces was a native C++. The only managed code that we saw in the pipeline was when your code was handling a request for a .NET application. So if you had ASP.NET, you could have written modules in .NET, which would have handled requests sent to .NET. Okay, if this was a request, for example, for a JPEG file or for a CSS file, it wouldn't have reached your managed code modules. Okay, it's not the same in IIS 7. In IIS 7 and on, of course, I'm talking about 7, 7.5, 8, and on. There is a managed pipeline. Part of the pipeline is still native, but another part of the pipeline is managed code. So I can bring my own custom HTTP modules and plug them into the pipeline, which means that I can basically, for example, create my own compression mechanism. If you think you can beat gzip with the compression ratio, anyone thinking of creating their own compression mechanism? No, don't try that, okay? Neither a security mechanism or stuff like that. But if you do want to create a custom module, for example, for logging, for diagnostic purposes, stuff like that, you can actually plug it into the IIS pipeline, write it in .NET, and actually get that module working for every request that reaches the IIS server. This can be a request for an ASPX page, this can be a request for a web API service, this can even be a request for a JavaScript file, a static file that IIS will just pick from the hard drive. Okay, so you can write your own custom modules, and IIS actually uses some built-in modules written in .NET to manage stuff like authentication mechanisms, like caching mechanisms. There are some managed code that IIS already uses. So that's one of the biggest changes between IIS 6 and IIS 7. The only reason why you should choose to continue to use the classic pipeline is if you are unfortunate to still use ASP.NET 1.1. Anyone still uses ASP.NET 1.1? Great. Okay, so I need to talk to you later. Okay. The basic reason is because ASP.NET 1.1 treats the pipeline differently than the newest versions of .NET ever since .NET 2. There are changes in the classic and integrated pipeline ASP.NET 1.1. That's why we should throw away 1.1 and switch to 4.5. Don't switch to 2. Don't switch to 3.5. Don't switch to 4. Switch to 4.5. Okay. The third part of the architecture that has changed is the configuration files. Now, there was always that configuration file called machine config, that configuration file called the web config. We always had web config files in our own applications. But now we actually have two different things ever since IIS 7. First of all, the IIS configuration itself is now an XML file based on the normal schema that you are familiar with from .NET. So there is a file called applicationhost.config. It's under your Windows System 32 folder. And that file contains the entire configuration of your IIS server. So first of all, don't change it manually, because if you do something stupid, IIS won't be able to load. Okay, so back it up if you're doing any changes manually. It has a schema that you can use. You can open it in Visual Studio and edit the file using that schema so you know what you're doing. There are actually a few bits in the IIS configuration that are only available by editing the file manually, and they are still not available when you use the user interface, that iNet Manager user interface. But we won't get to that today. Okay, if you want to know those bits, talk to me after the session. But the main concept, in addition to the fact that this application host config is a standard XML file that you can edit, a bunch of the IIS configuration is now inside our web config files. Anyone have ever noticed that system.webserver section we have in web config files? Yeah, we have system web, that's ASP.NET. We also have system.webserver, that's IIS. We can actually configure parts of IIS from our own web application. Stuff like whether to turn on compression or not, whether to use failed request tracing, a feature we'll learn about in a while, whether to, I don't know what else is exposed over there, which URL rewrites to use. Those things that in IIS 6 we used to do manually in the configuration user interface, and usually it was only available for IT pros, now we can actually do it in our own web applications. Okay? That's the first thing IT asks me in IIS courses, how to disable. They can actually disable the access to that feature. And you can actually ask them to grant you more control over those settings. So for example, you can change authentication modes by default from the system web server, but you can ask the IT to open that feature. I don't know how much you'll have to pay to them in order for them to do that, but it is possible. So for example, first demo of the day. First of all, this is IIS Management Studio, if you're not familiar. How many people are seeing this for the first time? Okay, I'll talk to you later. So if I go to my machine here, these are all features of IIS, and one of the features here is called feature delegation. Feature delegation is basically the list of features that are exposed through the IIS configuration, either in the system web server in your own web config, or in the system web server section in the application host config. And as you can see, each and every one of these options has an option of read-only, read-write, or configuration read-write. If it says read-write, that means you can edit that in your own web config files. If it has read-only, it can only be controlled through the main application host config file. Okay? If you ask your IT to change something like the authentication settings to read-write, you will be able to decide which authentication setting to use, anonymous, digest, basic authentication in your own web config. If you try that now on your computer without changing that, you'll probably get an error message once you load your web application that you can change the security settings in your own web config file. Okay? Changing this to read-write, you will be able to do that. Okay? So if, for example, anyone here uses IIS Express on a day-to-day basis, yeah? So you can actually change that manually in the configuration file just so you'll be able to tweak the different types of authentication, because I don't know if you know that, but there is no user interface for IIS Express. And that is really annoying. Okay? The first person who will write a user interface for IIS Express, I will probably pay money to get that product. So, anyone? No? No takers? Okay. So, the first thing you need to remember, today with the new versions of IIS, you don't actually need to have a script file, a large script file that configures the IIS server for you. You can actually do about 80 or 85% of the required configuration inside your web config. And once you deploy it to a production server, to a staging server, to a testing server, the IIS will automatically be configured according to your web config. This is an important part and a very crucial part of IIS. And as I said before, a lot of IT are asking me how to disable that, so you won't be able to change the configuration. So don't tell them it's possible. Okay. Now let's talk a bit about the application pool. First of all, the concept of application pool is basically a way to decide in which worker process, in which executable my application will run, and whether another application will be hosted in the same process as my application. Back in the early years when we were using 32-bit operating systems, it was important to host applications in separate executables because, as you know, ASP.NET application have the tendency to reach a memory boundary which is very high. Okay, I saw ASP.NET application reaching 3 gigabytes of memory, 4 gigabytes of memory, even 7 gigabytes of memory after 1 hour of work. Okay, bad code, I assume. Didn't test that, but I assume that's the case. Now, in 32-bit applications, there is a limit to the size of the worker process. Okay, that W3, WP executable. Back in 32-bit operating systems, we actually had to split web applications to different worker processes, each web application in its own worker process. But having a web application in its own worker process actually caused each exe file to use a lot of memory, because each of the basic CLR, DLLs that you loaded to a web application actually took about 6 to 20 megabytes of memory. So if you had 10 applications on that server, you actually had 10 times 20 megabytes. Okay, so that's around, it's late in the afternoon, 200 megabytes of memory just for loading the CLR files. So one of the options of application pool is simply joining applications into a single worker process. So you can have one executable actually running 3 or 4 different web applications. It's useful when you are running, for example, in 64-bit environments. In 32-bit environments, I wouldn't recommend that, because once your worker process reaches that 4 gigabyte size, it can simply crash. Okay? But in 64-bit environments, you should probably try to use worker processes to group your applications. It will simply reduce the amount of memory it takes to load all the .NET assemblies. Okay? So an application pool basically groups similar applications that uses the same framework version, because it's all hosted in one executable. It defines whether it's a 32-bit or a 60-bit, a 64-bit application. You can actually run in IIS applications that are 64-bit and applications that are 32-bit. Okay, it is supported if you have, for example, third-party assemblies that are compiled to 32-bit. You can force IIS to run your worker process as a 32-bit process. It also defines the identity of the user running the executable. How many people are familiar with the user called application pool identity? Yeah, that's a new feature of IIS 7. Up to IIS 7, we only had the default built-in users of the operating system, network service, local system, or using a local domain user. Ever since IIS 7, we have a new type of identity called an application pool identity. Application pool identity is basically network service, okay, in a new name. It allows you to call other machines, but when it uses local resources, such as disk resources, files, and such, you can actually give specific permissions for each application pool to specific folders and files in your operating system by using that application pool identity. Okay, because back in IIS 6, we had all the applications in the machine running under network service, meaning all of the access to our files and folders, we had to give permissions to a built-in user called network service, meaning all our applications had access to the entire set of folders. Ever since IIS 7, with application pool identity, I can give specific permissions for specific application pools. That's a cool feature. Still, it doesn't restrict us from accessing remote machines. For that, you probably need domain users, but it's still a cool feature of security that was added in IIS 7. 7.5, by the way, the only difference is that they changed the default identity of an application pool to that application pool identity. Okay, that's ever since IIS 7.5. Now, the interesting things about application pool is actually the advanced settings. In the advanced settings, we can set a bunch of stuff, like whether we want the application pool to start automatically or not. We can set CPU throttling. We can set a whole bunch of things. So instead of just talking about each and every one of those, I want to show a demo of some of those features. So first of all, let me open a project with code that does the only thing .NET application developers know how to do, overload the CPU. You're not joking. You're not kidding, sorry. You're not laughing. I'm tired. Okay, so let's run this application. Let me open a task manager. Task manager. And let me just browse to a small. And let's take a look at our task manager. And as you can see, our IIS worker process is scaling up 85%, 88%, 92%, okay? Sorry, 78%, we are just overusing our CPU. This is just some faulty code that takes the entire CPU and just hogs all the resources. Now, one of the things that we might want to do, if we have a server that has several applications in it, we might want to limit some of our application pools from consuming the entire CPU of our server. So one of the things we can do is we can actually configure the amount of CPU an application pool will use. And if that application pool tries to use more CPU than that, we can actually throttle that application pool and provide it less user time with the CPU. So let me get back to IIS and let's go to the application pool configuration. I'm using the test application pool. So I'll go to advanced settings. And as you can see, there is a feature called CPU limit. I'm setting it to 25%. Okay, that's 1,000th of a percent, so it's 25%. And instead of no action, let me change that to throttle. Okay. Now let's do that again. And let's check the CPU this time. I didn't change the code. I just reran this request. And as you can see, we are limited. Okay, so it's not exactly 25.0%, but it's not 99%. Okay, so that is a cool feature if you have an application that you don't know exactly who wrote it and you don't want it to hog the entire CPU. You can just put it in your IIS server and just select to limit the amount of CPU that that application pool can use. Okay, so that's complete. So that is one of the options, for example, we can do with an application pool. Now, another cool option of application pools is for the sake of diagnostics. Who here had their application pool crashing every couple of hours? Okay, every minute. Okay. It happens. What can we do? Well, we are still developers and we do bad code. And sometimes our application pool crashes for any reason that you may pick. One of the things that we want to do is, for example, to create a memory dump of our application when it crashes or when it hangs. Okay? So we can actually configure our application pool to run executables once our application hangs or crashes or is about to crash. And sorry. We can actually run executables such as creating a memory dump and storing that memory dump somewhere so we can analyze it later on and maybe even send an email to the developers that there is a new memory dump file that you need to check. Okay? So, for example, one of the things that I can do is I can go to process orphaning. Now, process orphaning is a nice feature. Process orphaning is a feature that allows you to keep a faulty worker process in memory instead of killing it. If there is a problem with your application pool, usually what IIS will do, it will just kill your worker process and start a new one instead. So if your worker process isn't responsive, if it hangs too much, it will just be killed and a new one will load instead. Actually, the order is a new one will load instead, and then the old one will be killed. Orphaning actually enables us to keep the bad executable in memory, run some script that will do something with that executable, and then allow us to clear that executable after we're done with it. So what I can actually do is I can turn on orphaning, and I can run a script that I wrote. Let's check that script. I'll show you what it does. I have a copy of it here. And that script, basically what it does, it runs a tool from sys internal called process dump. And what it does, it basically just takes a dump of that process and stores that in a file in the disk. You can take that DMP file, open it with WinDBG or with Visual Studio and analyze that to find out what went wrong. So let's do a small trick of causing an application pool to crash, because I'm a good developer. I don't know how to do it unintentionally. I need to actually crash it by force. So let's try to do that. Let's load another project. And by the way, all the code that I'm showing here is available online. At the end of the session, there is a link. You can go ahead and download both the slide deck and the code samples if you want to try to crash your machine at home or at work or in the production environment, whichever you choose. So let's look at orphaning. What we have here, we have a small application that what it does, it basically just sleeps for a whole lot of time, causing my application to hang. And let's see what happens when I do that. So first of all, let's do the following. Just I can do one more thing. Okay. Just look for the worker process. Here they are. Okay, so I'm taking a look at this one, and let's fire this baby up. Okay, one is not enough. Let's do a bunch of these. Tell me when to stop. Can go on like this all day long. I think that's about enough. Now, let's just go to our worker process and we'll do something nice. Let's just right-click and cause a hang by suspending the process. Now, what happens in the background is that IIS actually pings the process every couple of seconds just to test if that worker process is responsive or not. If there is some faulty code in your process, the worker process will be stopped and it will be killed and a new one will load instead. Okay, IIS is just pinging it to see if it works or not. As you can see right now, a new one started. And let me just verify that it actually did something. Okay, and as you can see, we have a dump file on the hard drive. We can take that dump file, open it, for example, with Visual Studio. You are familiar with the concept of opening dump files in Visual Studio, right? It exists ever since, I think, Visual Studio, I'm taking a risk here, 2012, I think. Anyone? Sounds right. So I can now debug this dump file. And if I want to know exactly what happened here, I can, for example, see the list of, let's see here, what do we want to watch here? The parallel stacks. Just verify that I'm opening the right one. Yeah. Okay, so I'm opening the managed stack just to view all the stacks that I had, all the open threads that I currently had. And as you can see, I only had one type of request here. I had 7 different requests, as you can see here, but they were all for the same ASPX file. Now, if I just watch this page load, I'll see that all of those threads were waiting on the page load. if I go on ahead and just browse through every one of these threads, just double-clicking will open the file. Let me just make this smaller. Okay, so you can see that this one, the first thread, is actually sleeping. That probably caused a problem for other threads. Now let's just see what the other threads are doing. The other threads are basically, waiting on a lock. Okay, all the other threads are waiting on a lock. So if you have a handling application, an application that had a couple of problems, you can actually very easily create a dump of that application, a memory dump of that application, open it in Visual Studio, and as long as you have the source code, the PDB files, you'll be able to view that code easily and just analyze what happened to that application. Okay, so a lot of times in ASP.NET, it's because of locks, it's because of throwing exceptions from within new threads that you started up. That sort of things will cause IIS to crash and to hang. Any questions so far, by the way? Yeah?
Is that feature available in all versions of Visual Studio?
Sorry, I can't hear you from here. Is that feature?
Is that feature available in all versions of Visual Studio?
Analyzing the memory dump?
Yeah.
Since I've been using the ultimate version ever since 2010, I actually don't know the answer to that.
Visual Studio 2010 for the
All editions. Okay, good to know. Every once in a while, people ask me about the edition of Visual Studio, if it supports one thing or another. I tell them, well, I'm always using the ultimate version, so honestly, I don't know. But there is a great page on Microsoft.com which has the different editions of Visual Studio and a list of what features supported in every one of the editions. So if you do want to use the orphaning feature, it's quite easy to configure. Let me just kill the process that I suspended before. It's not here. Is it here? No, it's not here. Okay. Great. I can kill this. And I can kill this too. Okay. So orphaning is also another cool feature of the IIS Application Pool. Let's take a look at some other things that you have in the application pool. So for example, there is a feature called Rapid Fail Protection. Rapid Fail Protection, what it does is basically, as I said before, pings your worker process to see if it's working or not. If your worker process crashes and loads again, IIS will remember that it crashed. If your worker process keeps on crashing again and again, IIS will actually notice that. It checks how many times the worker process has crashed over a period of time. So this here is set by default for 5 crashes during 5 minutes. So if there are more than 5 crashes in a period of 5 minutes, IIS will shut down the worker process. Now, a logical reason why this might happen, if a request is sent to the server and that request causes your worker process to crash, IIS will load a new worker process and will send the request again to your worker process because IIS still has a request that wasn't answered. So if that request causes your server to crash, it will just crash again and again and again and again and again without ever finishing to process that request. So having rapid fail protection is actually the best way to stop everything, shutting out. There's something wrong with your worker process, please check it. And one of the things that you can actually do is that you can place here a small command line that will send you a text message, will send you an email, telling you that this worker process is causing issues, please check it, okay? So if you have any way of sending emails by connecting to a simple SMTP client, add your script in that line, and it will execute every time IIS shuts down a worker process by force. Okay, so that's a really nice feature. Of course, in addition to that, you have other things that have to do with recycling of worker processes. Some things that you should know about and disable them. This feature, for example, anyone ever wondered why IIS recycles your worker process every couple of hours? Anyone notice that? That IIS automatically recycles processes about every 27 hours. That's built into IIS to work around a problem known as a bad developer. Okay? When you have bad developers and you have bad code and you have worker processes that takes too much memory, IIS automatically resets every worker process 27 hours from the time it starts to run. Now, 27 hours is a very nice number. It's just a prime number. No, it's not a prime number. It's just an odd number that makes sure the worker process won't reset on the same time each day. Problem is, it tends to cause issues, for example, by resetting your application pool sometime in the morning after all the people come into the office and start working. Okay, or just before people want to check in the changes and save the changes before they go home, the worker process suddenly restarts and everything crashes. So if you are good developers, or if you hire good developers, and your worker process uses a decent amount of memory, just disable this feature, okay? Clear that value or set it to, I don't know, 9 million minutes, okay? You don't actually need to recycle your process every 27 hours unless you have a problem with that worker process. So that is a feature you should consider disabling. If you do want to recycle your process every once in a while, prefer to use specific times and recycle your process in the evening if you're building an application that is used locally, not internationally. Otherwise, recycle it during weekends or during holidays or stuff like that. Okay? But other than that, prefer not to use the auto-recycle because it just isn't that helpful. Unless, of course, you're bad developers and you write bad code. So these are some of the features of the application pool. And I do hope I told you some new stuff now and that you wrote them down and you will try them back at the office next week. So let's talk a bit about the features of IIS and how it can actually help you develop better applications. So the first feature I want to talk to you about is compression. How many people know that they activated the compression in their IIS servers? Okay. How many people think they have compression but they never tested that? Okay. That's probably the case because when you install IIS automatically installs compression modules. But it only installs a compression module for static content. Static content is all those files that you have on your hard drive that are just served to the client, such as JavaScript, images, CSS files, text files, that sort of stuff. All your dynamic code, all of your managed code is actually not being compressed. To compress dynamic code, you actually need to install an additional module of IIS. It's not installed by default. So if your IT don't know how to install IIS properly, they probably just press next, 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 finish, and they didn't install that module. And that module is the dynamic compression module. So first of all, if you want to check if you have the dynamic compression module or not, go to any website or web application that you may have, open the compression option. By the way, if you don't see a compression, this means that you probably didn't install any of the compression modules. If you are able to check the dynamic content compression checkbox, that means you probably have the module, you just didn't turn it on for your web application. Okay? If it's disabled, that means you don't have the module. Now, what's the difference between static compression and dynamic compression? First of all, static compression is a one-time compression. When you require a static file from your hard drive, for example, a user requests a CSS file because it's a part of your web application. IIS will compress that CSS file, store a compressed version of that CSS file in the hard drive, and every consequent request to that CSS file, IIS will automatically provide the compressed version. You can actually see that list of files if you go to your IIS folder. Usually it's c/initpub unless you change that. There's actually a temp folder here with IIS temporary compressed files. So each and every one of your website will have that, will have a dedicated folder. Yeah, let's continue. And this one doesn't have any. Let's see what they have. So it's for each and every one of the application pools. So I can go ahead and check content of. Okay, so for example, jQuery. Everyone knows what jQuery is, right? Everyone knows generally what JavaScript code looks like, right? Okay, this is not the minified code, so let's take a look at that code. And this is not JavaScript, okay? This is a compressed file of that JavaScript. So all of your code is actually, all of your static files is actually being compressed by IIS. It takes a bit of CPU time to compress a file, but afterwards, all of the requests that arrive to IIS provides a compressed file in advance, and it just uses a whole lot less of resources. Dynamic compression, on the other hand, can't compress and save the file, basically because, well, it's dynamic. Okay? So when you return a response from an ASPX file or from a web API service, that content can always have different values for different users, for different times when you send a request to the server. So we actually need to compress it just before we send it back to the client. And that's what dynamic compression is for. So when you enable dynamic compression for your content, every dynamic content that you have in your code will get compressed just before sending it back to the client, which means that you probably have some more CPU time being spent on the compression itself. That's usually why static compression uses a higher level of compression than dynamic compression. Okay, if you have a lot of CPUs on your server and you're not bothered with the fact that it will use some CPU, you can actually increase the compression ratio of dynamic compression if you want it to be extra compressed. So basically all you need to do is just check that checkbox to verify that you have dynamic compression. So turning it on is the first thing you need to do, but unfortunately it's not the only thing you need to do. As I said before, once you check the dynamic, every dynamic content that you have will be compressed. Now, how does IIS know when a content is dynamic? I mean, yeah, static is what you bring from a file, but is dynamic necessarily everything that is not from a file? Everything that has a handler that generates the response? Not necessarily. The compression, the dynamic compression, and by the way, also static compression. For example, did you notice that images don't get compressed by IIS? It's kind of logical. I mean, JPEG is compressed, right? PNG is compressed. There is no reason to compress that again. You probably won't benefit anything from that. You probably even lose something for that because compressing a compressed file can generally increase the size of the response. Basically, IIS has a list of MIME types, content types, and for each of them, it tells if to compress it or not, if it's for static or for dynamic. So for example, XML content, CSS content, JavaScript content, all that content according to its MIME type, that content type that you see in responses, IIS compresses all of that. Okay, so if you return, for example, an HTML from an ASPX page, that will be compressed even if you use dynamic compression because that's a default in IIS. If you're using a web service that returns XML, XML is also one of the MIME types that IIS will automatically compress for dynamic compression. Now, I'm missing something. What is the other option of responses that will return from web servers? Which other type of content? We have HTML, we have XML. What other content do we have? JSON, okay? Now, that's the strange part. JSON is not in the list of MIME types to compress in dynamic compression. So, just so you'll see how to actually add that, let's take a service that returns a JSON object, just so I'll be able to brag and show you how good the compression ratio of IIS is. So first of all, let's do it without compression. And let's open Fiddler just to see the size of those messages. How many people here are familiar with Fiddler? Okay, those who didn't raise your hands, are you web developers? Yeah? No? Okay, because if you are web developers and you're not familiar with Fiddler, get familiar with Fiddler. You'll probably need it, if not tomorrow, then the day after. And if you didn't use it so far, that means that you're spending too much time on debugging your code, okay, because you can do it faster with Fiddler. So let's go ahead and where do I have that one? Okay, so I'll try to browse this API controller. Let's browse that. Let's use Fiddler to see exactly the size of the response, the content. So give it a couple of seconds. Here we have it. And just let me check. The response is 1 megabyte in size. Okay, it just has a list of a whole lot of JSON objects. Okay, basically the raw response looks something similar to, come on, it's a large, and it's a WinForm application, so this is the response. Okay, now this is currently not compressed. Let's turn on compression, and I'll show you how I added the JSON compression support. So first of all, let's go to the service with JSON compression, turn on dynamic compression. That is, by the way, going to be stored, that setting going to be stored in your local web configuration file, the application's web configuration file. And you can actually know that before you click apply, just check the lower left-hand side of the screen. Let me just show it to you. And it actually shows you where that configuration is going to be saved. That configuration is going to be saved in my service with JSON's web config file. Okay, if it's something that I would have changed that need to be changed in the application of configuration, such as authentication or stuff like that, logging, it would have said configuration file application host.config instead of a web config. So by changing the configuration inside IIS, you can actually tell where it's going to be stored. Okay, so that's also something important to note out. So I'm applying this, and of course that before I apply this, I added the JSON MIME type to my dynamic list support. To do that, go to your computer, scroll down to the configuration editor. Configuration editor is a cool tool. It actually provides you with the entire set of configuration that you can do on top of .NET applications, system web server, systemnet, everything you can configure in a web config file. And in system web server, I will go to HTTP compression. There is a list of static types here. There is a list of dynamic types here. There's also some stuff like what's the minimum file size for compression and stuff like that. And let's open the dynamic compression. And as you can see, we have a list of MIME types. And the last one, I actually added that a couple of days ago. Okay, I added the application/JSON and told it, yes, please compress that MIME type. Once I add that and restart IIS, you actually need to restart IIS in order to get that to work. All I need to do now is replay this request. And if I check the response, so the first one was what? 1 megabyte, right? The second one is about 270K. Okay, so that's a reduction of about 73% in size, from 1 megabyte to 270K. Yeah. It's available ever since IIS 6. Okay, good to know. In IIS 6, best of luck to find that configuration because it's buried somewhere in the configuration tabs. In IIS 7, just open the compression and enable that. So compression is a good thing, and you should use that. And by the way, you can use tools like Fiddler or YSlow and other diagnostic tools that test your web application to verify that you're actually using compression in your code, okay? In your IIS server, sorry, it's not from code. The next thing that IIS provides you in addition to compression is caching. Now, I know there is caching in ASP.NET, but IIS also wants caching of its own. So basically, by using IIS output cache, it's almost 99%, 99.99999% identical to the ASP.NET cache. Only I can also cache static files. So if you want to provide a faster way to give your users static files, in addition to having them compressed, you can actually store those static files in memory and provide them from memory to the response directly. You can even instruct IIS to store them in the HTTP.SYS driver So it won't even have to invoke the IIS code, the C++ code, and it can provide you a more improved, faster throughput for static requests. Okay? So I can actually turn on IIS output cache, tell it to cache, for example, ASPX pages or CSS pages or all the pages. Don't do that because it consumes a whole lot of memory. Okay? But you can tell it to do it in kernel mode, user mode, and one of the things that you should be careful about is the kernel mode part, because kernel mode actually caches the content before it reaches IIS, before it's authenticated. Okay, before the request is authenticated. So if you're planning on allowing only authenticated users to get the cached response, only enable it in user mode. Kernel mode will automatically provide the cached content. You won't be able to change that. Okay, you won't be able to control whether to provide it to an unauthenticated user or not. To control caching, sorry. To control caching, just let's see, I should have it here. Output cache. Okay, just add the type, define an extension that you want, whether it's user mode caching or kernel mode caching. If you're using user mode caching, you can also vary the different versions of cached items according to query streams and HTTP headers. So for example, if you return different responses according to the user agent that requested the response, you can actually store different versions of responses according to that header, to that user agent header. Okay, so it's just check the headers, add user agent. Okay, and you'll have different versions of the cached response for each and every one of the user's agent that you have in your application. Okay. So output cache is nice. One of the features that we can use, you can even ask it to cache compressed content. It will use less memory. Now another option that you have in IIS is URL rewriting. Anyone uses URL rewriting rules? Cool. It's useful, right? Just to fix bugs other people did and when you don't want to change the code. The concept of URL rewriting, it's a simple module that is placed in the pipeline. It looks and checks every incoming request, and according to rules that you create, it is able to change the request URL before it continues on down the pipeline. It can change the content of the request. It can also be activated on responses and change the outcome of responses. So for example, if I'm returning an HTML page, I can actually create a rewrite rule that will change several elements in the HTML response, and for example, do, I don't know, lowercase for all the external URLs that I'm using, or change the URLs of images and CSS files to point to other servers, to point to CDN servers, for example. Okay? I can identify URLs that are supposed to be HTTPS and they were sent to me as HTTP and redirect the user to HTTPS without needing to present a page telling them to please use the HTTPS page. Okay? I can do a whole bunch of stuff like enforce all my URLs to use lowercase, so I'll have better search engine optimizations, SEO. Prevent hot linking from people using my images and my CSS files. I can prevent people from adding trailing slashes to the URLs because that affects SEO. I can even do reverse proxy. A reverse proxy in IIS is a very cool feature. Let me show it to you. That would be a better way of demonstrating that. Reverse proxy basically means that instead of redirecting the client, I will actually take the URL the client has asked, I will change it and send a request on my own. The IIS server will send a request on its own to a remote server, get the response, and return that response to the client. It's basically a reverse proxy. So let's look at the application that I have here. It's a basic MVC application, nothing that unique. But there are a couple of things here that I want to show you. First of all, let's look at those images, those numbered images. here on the left. As you can see, if I check the properties of this, so let's, okay, let's take this one. So if I look at the image URL here, you can see that I'm pulling it from the web application itself, from a folder called images, order list1.png. Now let's go to my web application and take a look at that images folder. Can anyone see it? It's not here, right? And let me just, to make sure I'm not bluffing here, let me open this in Explorer. There is no images folder here. What actually happens is the following. Let me open this in IIS, show you what happens here. You open rewrites. I have a rule here, get images from blob, and this rule states the following. Any request that matches the pattern images, okay, /*, meaning any file that I'm trying to get from the images folder, please rewrite that URL and send it to the following address. Now this is not a redirect, this is a URL rewrite, this is a reverse proxy. IIS will actually call that web server, this is a blob storage server of Windows Azure, and will fetch the image from that server and return it to the client just like it's being in the server itself, okay? Just as is a part of the server itself. Now, if I look at Fiddler, for example, I will actually see that the URL rewrite application uses that image as its own, but it actually retrieves it from another server. Okay? If I would be able to attach a sniffer to IIS, I would have noticed that IIS itself is sending a request to another web server. That's one of the options. Another option that I did is, for example, for the jQuery that I have in this application, the jQuery itself originated from this application. So, for example, if I look at my code, I will see in my views just verify where it is. Okay. If you know MVC, scripts that render bundles jQuery will render the entire list of sources that it needs to use to get the jQuery and jQuery UI and all the other stuff. Okay. It usually retrieves the following list. Okay. So basically, it just brings the jQuery, whichever version .js. But if I look at the web page and look for jQuery, okay. Just check that. This is not what I want to see. Okay. A minute. Something is not working properly here. Script jQuery JS. Just to make sure I'm not using the minified version. Thank you. Thank you. They finished early. No? We still have half an hour. Oh, this is again a reverse proxy. Oh, sorry, it's a redirect. Okay, sorry. So if we look at the page, sorry about that, wrong demo. If you look at the page, you'll see that I pointed my code to a local jQuery, and also the rendered page itself showed that the code is trying to get it from a local file in my web application. But if I check it with Fiddler, I will actually see that when I try to pull the jQuery file from my application, I'm actually getting an HTTP 301, which is moved permanently, and I'm actually being redirected to a CDN server. Everyone familiar with the concept of CDN servers? CDN servers? Yeah? Okay, global proxy servers that provide you faster access to study content. And I'm actually being redirected to a CDN instead of fetching it locally. One of the reasons why this is worth doing is because when we create web applications, we tend to use our own, jQuery files, our own JavaScript files, and we do that for debug purposes. When we move to production, often we would like to switch from using our own jQuery versions to files from CDN servers. So instead of having a process that will change all of our HTML links when deploying to production, instead of using all sorts of applications that will do find and replace, we can just basically create those URL rewrites, put them in comment while we are developing. Once we switch to production, have that URL rewrite run, and it will just change every link on the fly once a response is being sent to the client. Okay? Or when, if you want to use redirect, it will just replace the URL and redirect the client to that exact location. And this is, by the way, a 301, not a 302. Anyone knows the difference between the two? 301 and 302, moved permanently, not? The difference is that once it's moved permanently, the local browser will actually cache that page, and it will return it every time the user requests this page. So every time I request a local application file, we'll actually get a CDN from the cache, instead of it not knowing that it came from a CDN, going to the server again, getting a 302, and then going back to the CDN. We'll actually know that these two addresses relate to each other. Okay, there was a question? Yeah, I can do some options. Yeah, I can tweak the bundling code of ASP.NET to do that in release mode instead of debug mode. Yeah, I can also add, yeah, there are a bunch of stuff that I can do to minimize my code and to create bundles of it. Yeah, but just a few examples of how to do it with your yeah, another question. The moved permanently instructs the client to cache the response and state that that response relates to the request the client sent. A 302, a moved temporarily, means that the next time the client will need to send that request, it will resend that request and will be again returned with a response saying, please go to another server. The contents of the file. Yeah, yeah. If I want to return a temporary redirect, I just need to go to IIS, and instead of a permanent, just choose found, and that will return a 302. Okay, and that won't cache the file. Okay. So URL rewrites are cool. Try to use them as often as you can. Another feature, and this one is new. I've been talking about IIS 7, IIS 7.5. This is a new feature starting with IIS 8 called application initialization. Now, with a show of hands, how many people are loading data from the database and store it in local cache when the application loads for the first time? Okay, a bunch of us, right? The application loads for the first time, we load a bunch of information from the cache. What happens to users who try to use the application during that time? Either they will wait or they will get strange behavior, right? So one of the things that we can actually do is we can tell IIS, once IIS starts, once our application pool starts, okay, for example, if it crashed and then started again, I want to execute a specific set of code immediately when the application pool starts. Even more than that, if anyone is sending requests to the server during that initialization time, I want them to get a specific response saying, please wait, okay? So that is the application initialization feature of IIS 8, okay? It's a new thing. You can apply it quite easily in IIS. It only takes 3 steps. First one, go to your application pool configuration and change the start mode from on-demand to always running. On-demand means the first request sent to the server will cause the application pool to load and start executing. Always running means that any time the application pool reloads itself, it will automatically load all your assemblies into the memory, all the required assemblies. Okay? and it will be ready for execution. That will speed up the loading time of your application pool. The second thing, go to your web application properties. It's right-clicking the web application and selecting the advanced properties, and change the preload enabled from false to true. Simple, okay? The next step is a bit trickier. Open your web config file, locate the system web server, and add this block to the web server. Unfortunately, the schema doesn't support this block of code, so you won't get any IntelliSense, unless I think maybe it changed in 2013. The application initialization allows you to set the warning page the users will see while the initialization is executing, and it will allow you to select the initialization page you want to execute. Now, it says initialization page, but basically it's just initialization code. Okay, it doesn't have to be an ASPX, it can be an ASHX, it can be a URL that points to a web API service. Okay, anything that can run your code to initiate and load everything and rebuild your entire back-end data. So let's see what this looks like in an application. Let me just close a bunch of Visual Studios here and open the one that I actually want. This one. Okay, so for this application, for the trace requests, I enabled reload. Okay. This one is using application pool, a warm-up application pool. This is the warm-up application pool, and in the advanced settings I have always running. The third part was to edit the web config file. And in here, I have the application initialization. It will show you a warning HTML file if you try to browse to the web application during the time it starts. And sorry, it will try to run the default.aspx to initialize the application. Okay? The warning HTML looks like this. Okay? Basically that. So let's try to do the following. Let's have Fiddler here. Let's have our worker process shut down. Just first request. What do we want to retrieve? I want to retrieve test trace.ts. Stop. Okay. What I'm going to do, I'm going to crash the process just to make it start up all over again. And once it starts, it will do the initialize. It will sleep for a couple of seconds just to mimic a real initialization that pulls a lot of data from the database. And then I will try, during the execution of that default ASPX, to try to load other ASPX pages. So let's kill this warm-up, and let's go back to Fiddler. And I hope it takes enough time. And let's execute 10 requests. Okay, and you see I got a response quite fast. And that response says, wait, sorry. Okay, every request that I sent during that time said, warming up server, hold your horses. Once the initialization ended, which should have happened by now, let me just replay this request. As you can see now, it takes more time because the operation actually executes, and it says page loaded. That's the response I should have received. So the initialization page basically should load up the information from a database, do everything as fast as it can. During that time, all the users will see some sort of warning page saying the application is currently loading, please wait. Okay, don't go on the hold your horses page. Yeah. Sorry, couldn't hear you? Okay. Yeah, you will move it. You will move it because what happens is that if you have a lot of code in the application start, first of all the other requests that are being sent to the server will freeze and wait for the application start to complete. The second thing is that IIS itself, in the application pool configuration, has a limit of how much time it should take the application start to run. If it takes more than the allotted time, it will simply crash the worker process. Okay, it won't crash it. IIS will recycle the worker process. Hopefully the next one will be faster. Okay, this is actually set in IIS. Sorry. Here you can see a time in this, where is it? Startup time limit. Okay, you have 90 seconds to complete your load. If the application start doesn't complete in 90 seconds, the worker process will shut down. Okay, but it's more, it makes sense to put it in the application initialization instead of the application start. Application start shouldn't do anything other than just initialize global variables. Now, that feature is actually built in IIS 8, but it actually also exists in IIS 7.5. If you want it in IIS 7.5, you can just go ahead and download that module for IIS 7.5 and use it. You even get a special server variable that tells you if you are currently in the stage of a warm-up or not. So, any people here develop their own custom modules for IIS? Custom modules, anyone? No? Yeah? Some of you? So if you're in the job of building custom modules, you can actually, in your module, check that server variable. Let me show you the support faintly. Okay. They also completed earlier. You want to finish earlier? No? Okay. You can actually check that server variable and decide according to that, if you're in an application warm-up, maybe I shouldn't do what I need to do, like compression and logging and that sort of stuff. If I'm not in a warm-up, then I will do the other stuff that I need to do. Okay? So you can actually check that. Just go to the request, server variables, the app warming up, if it's in there or not. Okay? So that's another cool feature of IIS. Sense 8 built in, but it also existed back in 7.5. We just need to download that module to actually get you the UI that you need to have in order to do that. So the last thing I want to talk about is logging and diagnostics in IIS. How many people are actually using the log files and the trace request information? Cool, okay. I should have seen more hands, but that only means that I still have some work to do with you guys and gals. So first of all, let's talk about logging. You're familiar with that dreadful log file, right? That huge log file that doesn't actually contain any important information for us. The IIS logging is nice, the W3C logging, but it's not enough. First thing first, go to IIS.net and download a module called Advanced Logging. Advanced Logging is a module that, on top of the normal IIS logging, it actually allows you to log more information. Information, for example, from the HTTP request itself, from the HTTP response. It allows you to log server variables. It even allows you to log performance counters. So if you want to know exactly how much CPU you had available during each and every execution of a request, you can actually log that information inside your log file. You can even create a separate log file for every web application, something you can do with the standard logging of IIS. It creates a single log file for the entire website, not for a web application. And you can't even filter the IIS log. You can't tell it, well, for that request, for example, for a heartbeat request I have from my load balancer, don't log it because it happens every half a second. Okay? With advanced logging, I can actually add filters to instruct the IIS to instruct the advanced logging, don't log that request. Okay, I don't want to see that information. But basically, the end result of advanced logging is the same format, the same CSV format of IIS logs. So if you are using any kind of log parsing tool, you can actually open IIS logs in that tool. Are you using log analysis tools to open log files? No, right? No one is doing that other than IT sometimes. So just to understand what I can do with log files, So this is a log file, right? A bunch of stuff no one knows what to do with. So I can actually use log parsing tools. This is a tool called Log Parser Studio, which actually it parses logs, not necessarily IIS logs. So it has a whole bunch of logs it can parse. One of them is IIS. So I have here a bunch of options that I can do with IIS. For example, user agent report. So what is a user agent report? If you look at it, it basically performs an SQL query on top of your log file. You can even create your own SQL query if you remember how to do SQL sentences and you're not using ORM tools like Entity Framework or NIGOLET. Okay? There are people that don't even know how to use SQL, but they use database on a day-to-day basis. So all I need to do is just select the log file. I've selected it here, execute it, and I will get a response. I can even, if I want to show it to my manager, I can show it in a way they know how to read, which is graphs. Okay. So if you have any type, please show me a list of requests according to the location I got it from. If it's in the range of this IP, then it's from the European Union. If it's from this IP range, it's from the United States. Then you get a graph of how many users you have from different locations. You can even write custom functions, and you can even export that to PowerShell. Okay? I like PowerShell, so I like to point that out. So advanced logging is one of the features that you can use in order to actually do something with those IIS logs. For example, by the way, do you remember that CPU throttling I showed before? I actually added a log file. I created an advanced log file that logs all the information from my CPU performance counter. So if I go to advanced logs, to today's log, and I will look at the CPU throttling from before. This is the opening, and this is the CPU throttling. If I scroll to the end, okay, you can actually see the CPU limits where I had in the beginning the 92%, then I had the 32% CPU. Okay, so you can actually see that I grabbed performance counter information and logged it into my log file. So I can also do the size of my memory of my application. I can check the number of concurrent requests, so I'll know how to explain, for example, if a request took longer than expected. I can say that I have 100 concurrent requests executing at the time, so it's logical that one of the requests took longer than expected. I can do a whole lot of stuff with advanced logging. The second thing I have, if I want to debug my applications in IIS, is what is known as failed request tracing. Now, I actually find that name a bit lacking because it's not actually investigating failed requests. I consider it to actually diagnose faulty requests. Okay? So what is a faulty request? A faulty request basically is a response that was a 400 or a 500. If it was a 300 or 200, it probably was okay. If it's something that had to do with the client input, so then it's a 400. If it's a server thing, it's a 500. If one of those things happen, that is what I want it to actually trace. Okay. If I had a request that took too long to execute, a couple of seconds, even a minute, that might be faulty in my opinion. Maybe not in yours, but my opinion is if it took more than 5 seconds, probably something is wrong with that request, with that code. Okay. If there was a trace message that was a warning or an error, not an information trace message, are you familiar with .NET tracing? .NET tracing, ASP.NET tracing, okay, simply saying trace.write and it outputs it to an ASP.NET trace file. If a trace message was written with a warning level or an error level, that might trigger for me a faulty request that I want to check. So what is faulty request tracing, as I like to call it? It basically stores a trace file containing all the debug messages, the information messages, the warning and the errors that were outputted throughout the pipeline from managed code, from unmanaged code, from your own code. It outputs everything to a file. a separate file for each and every request. So when we output that content, whenever one of these things happen, I can actually configure for a web application, if a request takes more than 5 seconds, please create a trace file. The trace file will always be created in the background. The content will be collected, but it won't actually write the trace if it doesn't answer one of those situations. Okay, so you can set different traces for different URLs. A specific folder you want to trace 400 messages for a different folder you trace requests that take too long. You can select different trace levels. For example, you can select to just diagnose the ASP.NET pipeline without the native code pipeline. Just be careful of creating too many requests because it takes a whole lot of space on your hard drive. A request looks something like this. Just go to here. And it's failed request tracing. Okay, these are failed requests. And failed requests basically show the request itself, the status of the response. This was for a 200 response. So probably because it took too long, 16 milliseconds, that was probably my setting. And if I look at the compact view, I won't bother you with the request details, but the compact view, you will see it actually outputs every debug message that a module in the pipeline outputted. Starting from things such as which module executed, the application initialization module, the failed request tracing module, the rewrite module, advanced logging module. It shows every one of the requests and how much time it took to execute. You can actually see the time here, so you can actually notice when a module took too long to execute. I can see stuff, for example, if I'm using URL rewrite. For every request, I will see if the rewrite rule was applied or not applied. So if I'm banging my head against the wall trying to understand why the rewrite rule didn't work, I can actually go ahead and check the trace file to see if it was actually activated. Okay? And I just take the pattern and test it on my own if I see that it's not working. So you can use trace requests to get, for example, sub-status information. If you are diagnosing 401 messages and 05 messages, failed request tracing will actually tell you the sub-status of the response. So, for example, an unauthorized could be because your password expired, because your user is logged out. You won't see that information in the browser. You will see that information in the trace file on the server. Okay? So, to activate failed request tracing, what you need to do is go to IIS, go to your application. There is a failed request tracing option here. You'll have to turn it on the website level first, and then you can add a new failed request tracing rule. Select the file type you want, for example, ASPX. Select how you want to trace that, whether it's according to the level, the type of the response message. So, for example, 400 to 599. I can also tell it not to collect all the information, only for messages that took more than 5 seconds to respond. Next, specify which part of the pipeline I want to collect information from. For example, if it's a www server, which is my, for example, for the ASP.NET, I can check the verbosity and select the log level I want to collect, the different parts, if I want to collect the trace messages that ASP.NET outputs automatically for pages, and finish. That trace rule is created. By the way, it's created in your web config, as you see down there, and it's stored with your web application, so you can just deploy it to your application, to your production server, and get all the files there too. Okay? So that is quite a useful tool if you want to diagnose your code in runtime and see why it took too long to process. Now, just before we finish, I want to do a quick overview of IIS Express. IIS Express is now in a version similar to that of IIS. It's version 8.5. So that slide is a bit old. It exists ever since IIS Express 8, 64-bit, but we have today IIS Express 8.5. The main difference between IIS and IIS Express is this bottom line. IIS Express runs in the context of your current user, which means it probably running under an administrator account because you are administrators on your own machines. IIS, the default IIS runs in a different type of user. It's a restricted user, it's a built-in user, or if you do it in a domain user account, it runs in a domain user account. It runs in a different user, it will have different permissions on your operating system and on your environment. So don't rely on what you see in IIS Express. Always use IIS servers eventually to test your code. Because you might be writing to a specific location in the hard drive, it will work in IIS Express and it won't work in IIS. Okay? And the only problem with IIS Express is it doesn't have any user interface for management. The only way to configure IIS Express is from your web config, from Notepad by editing the IIS configuration file or using the command line APP-CMD. Okay? IIS, on the other hand, has the management, of course, and PowerShell, which is, as I said, very cool. Okay? Anyone uses PowerShell to manage the IIS servers? Okay, great. A few bullets about IIS 8.5. So first of all, good news. You remember the advanced logging that we had in IIS 8 as a module? It's now built in IIS 8.5. Okay. IIS 8.5 also introduces the suspension concept of applications, of worker process in IIS. We have suspension in Windows 8, if you're familiar with that concept. It suspends our application without actually removing it from memory. Now we can actually do that for worker processes. We can suspend them. They won't have any CPU usage. They will only have consumed memory. But once we need them to start running, they will start running immediately and won't have to incur all that load time. We also have options to send the entire logging of IIS to ETW. If you're not familiar with ETW, look it up. It's a very cool feature of Windows, not IIS, very cool feature of Windows to do tracing in real time. Okay, almost real time. So these are the new features of IIS 8.5. As I mentioned before, not that many features, but still cool. Maybe they should have changed that to 8.1. So before we finish, and you can go back home and tell your IT what you think about IIS and teach them about IIS, let's just...
Well, this doesn't embarrass you, Jen, but I find the best thing to do with a new employee is to size them up with a long, hard stare.
And this is just what I think about IT and why you now know more about IIS than them.
So, first day.
Yes.
Scary.
Yes.
Don't be scared.
Well, I'm not really scared.
You should be.
Well, isn't it?
Well, don't be.
Make up your mind.
So here you are.
Yes, really looking forward to getting to grips with
I'm going to put you in IT because you said on your CV you have a lot of experience with computers.
I can say that on my CV, yes. I've got lots of experience with the whole computer thing, you know, emails, sending emails, receiving emails, deleting emails. I could go on. The web, using mouse, mice, using mice, clicking, double clicking, computer screen, of course, the keyboard, that goes on the floor down there.
The hard drive.
Correct.
Oh. Well, you certainly seem to know your stuff. So, got a good feeling about you, Jen, and they need a new management.
Fantastic. So the people I'll be working with, what they like.
Standard nerds!
Okay, so now you actually know more than your IT about IIS, I imagine. If you want to learn more about IIS, just take a screenshot of all those links. Part of the tools that I showed, the log parser and all the other tools are shown here. The log parser, the advanced logging. There's a great tool for viewing trace messages. If you want to learn more about IIS, check IIS.net. It has all the documentation you'll ever need to know about IIS. This presentation and the demos are all online at that address. And if you need to contact me, my email is there, my Twitter account. If you want to follow me and listen to my rant about Microsoft and Azure and all other stuff, feel free. So thank you a lot for your time. Thank you for staying here and enjoy the rest of the conference.